This is the answer key for the exercise on concentration of solutions. For the first problem, a solution contains 40 grams of hexane and 10 grams of glucose. Calculate the percent by weight concentration of this solution. Now, hexane is a typical solvent in the lab, and we also have glucose, which is a type of monosaccharide. So in this problem, we're given the following information. We have the mass of the solute and the solvent. We know that glucose is the solute since it's in lesser quantity. We are asked to find the percent by weight or percent by mass of the solution. Now, in chemistry, we can interchange the terms weight and mass since we aren't really particular with the forces that are acting on our substances. We're concerned with reactions or whatever is happening in the chemicals themselves. So we can interchange the terms weight and mass. But in physics, it's a different story. Also, in most products that we have or find in the grocery, they interchange weight and mass as well. So the formula for the percent by mass would be gram solute over gram solution times 100. To find we have already the amount of the solute, but we don't have the grams of the solution. However, we know that there's a law of conservation of mass wherein mass cannot be created nor destroyed. This is true for reactions. This is also very true still for processes that are just phase changes like mixing. So the amount of your solution would just be the sum of the masses of the solute and the solvent. Thus, we have 10 plus 40, and we get a total of 50 grams of the solution. We then substitute our values for the solute and the solution, and you should get 20% by mass. Moving forward to question number 2. How much grams of sugar are present in 120 grams of syrup containing 30% by mass sugar? And how much is the solvent? So in this problem, we're given the mass of the solution, and we're also given the concentration of our sugar solution. We need to find the masses of our solute, which is the sugar, and our solvent, implied to be water since it's not mentioned. So the formula that we'll be using is still percent by mass. And we just have to manipulate the equation for us to isolate the gram solute. Thus, we can now solve for the amount of the solute. You have 0.3. 0.3% is changed into its decimal form, multiplied by the gram solution, 120 grams, and we'll get grams of the solute, which is 36 grams of sugar. Now, to calculate for the mass of the solvent, we have this formula which we have used already in number 1, and we can rearrange this to obtain gram solution minus gram solute. So you have 120 grams, which is the total amount or total mass, subtracted with the amount of our solute, 36 grams. So we'll get 84 grams of our solvent. Moving forward to number 3. So problem 3 goes like this. Rubbing alcohol is a 70% by volume solution of isopropyl alcohol. How much ml of isopropyl alcohol are present in 47 ml of rubbing alcohol? In this particular problem, our solution is the rubbing alcohol and our solvent is the water. Our solute is the isopropyl alcohol. So we're given the following information: the concentration of our solution and the total volume of our solution as well. We need to find the volume of the solute, and we have this formula for the percent by volume. Note that it's very similar to our percent by mass. It's still solute over solution, but instead of mass, we have the volume. So we rearrange the formula for percent by volume, and we should isolate volume of the solute. So you have this form, which is similar to problem 2, and we substitute. So we have 0.7 times 47 ml, and we should get the volume of our solute, which is 32.9 ml of isopropyl alcohol. We now go into problem number 4. A sample of vinegar is 5% mass per volume acetic acid in water. How much vinegar must you buy to have 80 grams of acetic acid? So we're given the concentration of our vinegar, which is the solution here. And we also have the mass of acetic acid, which is equivalent to the gram of our solute. We need to find the volume of our solution. So sorry for the typo. So we have the formula for our mass per volume, and we rearrange this to isolate the volume of our solution. So we should have mass solute over percent mass over volume times 100. And substituting the values, you have 80 grams divided by 0.05. So we'll get volume of the solution equal to 1,600 ml of vinegar. We now go to number 5. For number 5, ascorbic acid or vitamin C is a water-soluble vitamin A solution containing 80.5 grams of ascorbic acid dissolved in 210 grams of water has a density of 1.22 gram per ml at 55 degrees Celsius. Calculate the mass percent, mole fraction, molality, and molarity of ascorbic acid in this solution. We're given the masses of our solute and our solvent, and we're also given the density of our solution. We need to find 4 information out of this problem. So for letter A, in calculating the mass percent, you have this formula, and it's pretty straightforward because we're already given the amount of our solute and the amount of our solvent. So we just have to plug them in, 80.5 over total mass, which is 80.5 plus 210 grams. So we'll get 27.7% mass by mass of the solution. For letter B, we're asked to find the mole fraction. And we know that the formula for the mole fraction is mole solute divided by mole solution. But the mole solution is solved by adding together the moles of the solute and the solvent all together. We don't have the moles of our solute and solvent yet, but we can solve for them because we have the formula for vitamin C, then we can calculate for its molar mass. Also, we calculate for the molar mass of water. And recalling our lesson on stoichiometry or in the mole concept, we know that to find the mole of a substance, we need to divide the mass with our molar mass. So you have 80.5 grams divided by 176.124 gram per mole for us to get this value for the mole of ascorbic acid. Similarly, for water, we do the same. We divide mass with the molar mass, and we should get this value. Since we already have calculated for the moles of the solute and solvent, We can now substitute this into our original formula here. And with this, we can calculate for the mole fraction, which is 0.0377. Now, mole fraction is a unitless number because both numerator and denominator are in the unit of mole. But if you insist to have a unit, you can write mole ascorbic acid per mole solution. We go to letter C, which is calculating for molality. And molality is or have this formula here, mole solute over kilogram solvent. Now, out of all the concentration expressions that we have encountered in chemistry, it's only molality that is expressed in per kilogram solvent. All the others are expressed in either mass or volume or mole of the solution. It's the only concentration expression that takes into account the solvent only. Now, to calculate for the mole solute, we have done that already in letter B. So we have this already. And then for the kilogram of the solvent, we're given the amount in just in grams. So we just have to convert that in kilogram. We have 0.210 kilogram of water. And again, we have already the required variables here, and we just have to plug them in our formula. So you have this, and we should be able to calculate the molality, which is 2.18 molal. Okay, note that we pronounce the small m as molal, or we can also read this as 2.18 mole per kilogram. Moving on to the last sub letter of our letter, you have molarity. And for molarity, this is our formula, mole solute over liter solution. We have the mole of the solute already. And for the liter solution, we have to solve for this. Now recall that you had a lesson on density already even in grade 7. So density is mass over volume. And if we rearrange this formula, we can isolate for the volume of the solution, which is mass over density. We can easily calculate for the total mass of the solution, because we can just add together these two quantities here. And then the density of the solution is given in the problem as well. So if we want to solve for volume solution, we divide 290.5 gram over 1.22 gram per ml. This should give you 238.11 and so on ml of the total solution. And now we can calculate for the molality. So you have this. Okay. This is already in liter since the problem is in the formula asks for the solution in liter. So this ml is just converted into liter, which would give you this value, 0.23811 and so on. And so the molarity of our ascorbic acid solution is 1.92 molar. Last letter is R, capital M. Or you can express it as 1.92 mole per liter.